So you can only bulge out a mesh so far.
Bob, let me ask thickness.
Yes, Nate.
Yeah, the thickness, depth-wise. This is a good question because we're making
like this.
I got
this thickness.
Gotcha.
So in other words, the cases I'm working on, Nate, not the ones you and I have been discussing.
Sure.
I'm working on 3 standard cases where the width and the length is fine for the Phoenix V2, and the Phoenix V2 would work well. Simple hand. But the thickness, there's anatomy that sticks down, and you can't slide into the Phoenix mesh very well. So I've been sending test bonds back and forth. I guess you could mold, but we're homing in on it. It's taking a couple of mailings back and forth between the coasts. So, but it's working. If I had your skills, Nate, it would be easy.
Well, okay. So what I'm trying to do here, Bob, is I'm planning to put it all in OpenSCAD, and the whole point is. So in OpenSCAD, you can add and remove parts of a model. And so I want to make it so you can add and remove finger slots, as well as the OpenSCAD by itself will be able to take care of depth and width of the palm cavity. And so we'll have a lot more control over that in X and Y scaling, X, Y, and Z non-scaling.
Okay, I've used OpenSCAD, Nate, before on other devices to scale. Based on the measurements, and that works well. That has been very good. So I'm a little familiar with it.
Yeah. So that's my plan, and the beauty of that is, so anybody that's just doing making, like yourself, can just use OpenSCAD and pick which fingers they want to toggle on and off in the little OpenSCAD menu on the side.
Okay.
And that takes care of that, right?
Sure, it does.
Okay, cool. I've got good tricks for you guys.
Great.
Okay, so normally I announce at this point that we're going to get started and that we are recording and all that, but I'd actually like to include part of that conversation that we just had there, if you guys don't mind, because there was some interesting information. Sure. So is that okay?
Absolutely.
All right.
Yeah, for sure.
Great. So I'll start it from just before that, and we'll go ahead and get started since we have a few of us here. Just a quick review of action items, then we'll get into our presentation from Nate. Our action items were all from Alex this week, and they were all done, so we don't need to spend a lot of time on them. He sent Jen a copy, or he's working on getting her the database from EWC in the format she needs, and we've added that new feature to our development list for having a direct link to profile pages, and we're all connected with John on the badge importing effort. So those are all taken care of. Alex is pretty tied up with other initiatives, and we just decided that we probably can't afford to have both of us in these, so I'm going to be giving the e-NABLE Web Central updates, and we'll communicate things back to him. So that's all for the action items. We'll move on now, and Nate is here to give us an update on what he's been working on. So Nate, if you want to go ahead and, I don't know if you want to just be on video or share your screen, that's up to you, but I'm going to go ahead and go full screen here so we can see you. And
okay.
For the rest of us, because we still have some potential bandwidth issues here, I'm going to suggest that we go ahead and turn off our video and mute ourselves while Nate is presenting, just to conserve bandwidth, and then we can come back on.
All right. Well, thanks, Jeremy. I suppose I should probably start with just an explanation of the NIOP team, because I get a lot of questions about what the NIOP team actually even is or what it represents. And so NIOP itself stands for No Insurance Optimized Prosthetic. And the goal of this entire modular arm system is to make a modular arm system to fit most situations, from traumatic amputation or a congenital limb difference, and make it easy to assemble and then to use by the end wearer. We're going to start with a body-powered system like what e-NABLE's been used to using and known for, and then we will take those body-powered systems and graduate them up to powered options. And in that, we will probably be working with powered exoskeleton type of options for assistive devices to be able to, for people that have paralysis, to be able to move their arm, as well as people who are missing their arm entirely. So it's a kind of an aggressive goal, and it's a new angle for a lot of the e-NABLE devices. But a lot of the parts actually share commonalities with each other and common design aspects. And so it's actually working out really well to do the two at the same time, even though it is a lot of work. I wanted to probably start off with just explaining who's in the team a little bit. There's so many people, I'm going to try and just breeze through it as quick as possible. But the main core team consists of myself and Alexandra Lamp, who has been a lifesaver with a lot of this. She's a really adept industrial designer who lives in Holland and Germany right now. And she has been instrumental in getting, especially the quick connect wrist design done. She's been helping out with a lot of things, though. And then we have Chang Lu, who's the prosthetic student who's been out and about helping everybody around in the e-NABLE world. She is super smart and has really helped a lot to cut down on the R&D time for a lot of the devices we're working with. She brings that professional prosthetic aspect into the design, and it was really hard to beat. Like, her comments at the beginning were over the top. Like, she would be asking me things like, I think this foam you're using is probably going to mold, or things like that. And so her comments were really excellent because they really get into what people who wear the prosthetic are going to be up against, rather than just the mechanical issues of the industrial design aspect, you know. And then more to the industrial design aspect, we had Donna Zimmerman and Maria Escala and Leland Green, who were all part of the cataloging committee. They still are, but that's how I initially met them all. And they helped me to know about what devices were available, what concepts were in play, some of the popular things that worked, what didn't work. A lot of that stuff cut down on my R&D time significantly too. And Donna has a little team of her own. I don't want to forget thanking Lydia, who's been a huge help to help Donna make progress. And Donna's done other cool things with the designs I've brought forward with her team. So it's been a really synergistic design process amongst the community here. I've also got Daniel Ulrich, who's my chapter member, and for Helping Hands of Littleton. He's been a huge help getting my printers up and running. So I had some issues with some of the ones I was working with. He's getting me going with Octoprint, a bunch of the cool things I should have been doing before. And the one person I really need to thank out of all of this is my helper buddy, Lorenzo, who is my right-hand man. And I swear I would not have even half of this stuff done for prototyping if I didn't have him to tie knots, cut nice, clean cuts places. He's a retired master machinist who used to work on the cargo bay doors for the space shuttle and NASA. And I don't know how I got so lucky to get him to put things together, but the entire community is benefiting from Lorenzo because he's 79 years old, but he's in way better shape than I am. He's just an amazing person. And so in order to make these designs a real world thing, we've got beta testers. So I've got Ahmad Haj Musa in Syria and James Quilty working with a team in Thailand, both assembling the NIOP devices and giving me feedback on the assembly, because that's one of my main goals, is to make sure it's easy enough to assemble. Now, I was talking about Leland earlier, but he's part of our noobs squad now of the new designers we've got helping out on the team. Leland's really stepped up. He didn't know Fusion 360 before all of this, and he just jumped into it right away. And now he's doing the design work on a couple of the projects we have. So it's really excellent seeing his progress. And he's now dragging Rich Brown along with him, which is really fun, because Rich is a retired gentleman too, and he's never done design work before. But he's been frustrated waiting on a case he's been working on, and so now desperation is wielding miracles and turning him into a designer of all things, which is really cool, because now he's going to be able to fix his designs on the fly. As we get the things ready, he'll go work with the recipient on his end, and he can kind of adjust for hot spots or other things like this. And we're actually doing a special device with him, the Exo Glove, which is a glove meant for stroke or paralysis victims. And so it's got some special mechanics involved with it that we aren't using on some of the other systems. So that type of rapid prototyping with working on his end also is going to make the R&D time on that device like half of what it would have been otherwise. So all of these things work together in an amazing way. I've got Nelson Walsh, who's a mechanical designer down in Australia, who's going to be helping out also. And then I've got Bob. who's on the call actually, and he's helping me to come up with some shoulder modules for some special cases that he has going. But it's really good because we're pushing the envelope in all kinds of different directions with this. All right, so I don't mean to just rush through everybody because there's so many more people. It's really rough to pick which ones get highlighted. I should say, though, I have an entire team of Mayo designers working on this, working with Tanya Lurch and the Sage Hill School in California. They are junior and senior students for the moment. Aaron, the head for the team, is going to graduate this year, and then the 3 juniors this year will then be 3 seniors for next year. Hopefully, we'll see how things go. But they've been really good at putting together a Mayo design for me, and we will be incorporating part of the motorized aspects of these using their work. So they've been instrumental at taking us to the next step, which is going to be important, and we'll all see that very soon. I do need to apologize that I don't have my designs on Thingiverse yet. I've been slacking on that horribly, and I should be flogged for that one. I also intend to get a lot of our design projects posted up on WikiFactory, so we can use the design tools there within the WikiFactory community to get these projects, some of the individual tasks addressed and done by random designers that may have time. I like that functionality, and so I'm going to try and play on that as much as possible. But I am not there yet, to be fair. I'm going to try and run through all the devices really quick, and then we'll do questions on all of them because there's going to be a ton as we're going too. So just in general, I want to go over some of the terms I use, which I know sometimes might differ between some true prosthetists and some of the other guys, because I might be using things just a little incorrectly. I'm using flexion for the gripping action and extension for the opening action. And then I've got voluntary open is when you move the action and it opens the hand up with the action. And voluntary close is when you move the hand and it closes the hand, like how the Kwawu is right now, or the Phoenix hand. And that will come into play because I'm trying to make it so it has an automatic grip to close the hand, and it'll be voluntary open it, but then you automatically are holding whatever's in the device hand. In general, when I'm saying TPU in a project, I'm saying any type of flex filament. So TPE or other flex filaments could probably work in that situation. But I use TPU as a general term just to kind of cover flex filaments. And then in general, I want to be using the OpenSCAD for sizing on all the NIOP devices, similar to how the Kwawu works right now, to get the functionality that I was discussing with Bob earlier. So on hands, when we're making a Phoenix hand type design, mechanically it's similar to the Phoenix hand. And in things like that, we will have it set up so you can remove or add, I suppose just remove fingers to put holes in. So if you had a partial hand with partial fingers, you could make holes to slide the recipient's fingers through the device. And all of the customization for that could happen within OpenSCAD and avoid the issue of the maker having to know design software. So I think the functionality that we're going to bring with the OpenSCAD is going to be huge, in addition to just the fact, once you learn how to do the scaling, it's going to work for all NIOP devices, just like it works for the Kwawu right now. So I'm trying to keep the same mentality that Jack used, because Jack's done a really good job with training a lot of the community on how to use OpenSCAD for that purpose right now. So I'm playing right on top of that. So I'm going to try for as little change from what Jack had done as possible. All right, all that said, here we go with the shindig. We're going to make 5 main devices here. We're going to start with, most of them are all going to be framed around the look of the Kwawu. So the first device is an improved Kwawu design, where we will be eliminating TPU out of the design as an option. So you can still have the old option for legacy designs, like devices that are already out in the real world. If you need to make spare parts or whatever, this will work for that also. But the main point would be so that people that don't have TPU printing options can still print a Kwawu without having to worry about other materials other than just PETG or PLA, presumably, ABS, that kind of thing, plastic. Then we will have an advanced Kwawu, and the advanced Kwawu is going to be similar to the old Kwawu, but it will have a 3-segmented finger. And that will allow you for many more grip options and fingering positions. And that'll be a really good thing, I think. But we will have the options where those fingers can be added to the improved Kwawu design to make it the advanced. So it will be completely modular, and if you want the new fingers, then you can have the advanced design. But that would be probably the biggest difference between the two. There are a couple others I'll go through in detail here. And then we're gonna have a prayer hand, which is basically a phoenix hand in design, Kwawu look, but it's going to have a thumb that instead of being stuck down, will be able to fold up to the side. Now this is gonna be a passively folding thumb, so you'll require your other hand to push it up. But it's meant so, like how my Mayo won't do this right now, this is to solve the problem of the prayer hand greeting in Thailand and all kinds of places where that's the standard social greeting. It's so people with prosthetic devices can then do proper greetings. So that's the point of the folding thumb. It will probably be a TPU hinge in there, but I'm gonna try and come up with alternatives for this. So if you don't have the ability to use TPU, you could maybe stitch it with the fishing line, or there's other ways to make a close to indestructible hinge that would still function, but not require needing TPU. Now, I can't require it's going to look as clean as the TPU because it's hard to beat some of the functionalities of a 3D printer. But things like stitching with the fishing line can definitely make a high strength hinge out of almost no materials, same materials as you had already. Then Rich Brown, myself, and Leland are all working right now on the ExoGlove, which is the device we are creating as a glove to fit over paralysis victims, where they will be able to lay their hand into the glove, because one of the deals with paralyzed fingers is they don't slide into a glove very easy. So the whole device will need to be able to have your hand lay into it and probably just pop into the rings on the tips of the fingers, so you can put it on and then it'll strap across the palm. But it's going to be a whole new device as far as e-NABLE is going, because mechanically it will be both voluntary opening and voluntary closed. It will have a positive force direction going in both actions. So it's a little more challenging as far as the design goes, but it's definitely something that needed to be in the world. So it's a great thing for us to add. Now the fingers on the ExoGlove, the palm and the gauntlet are going to be very similar to a Phoenix hand, but the fingers will hook on and they will actually be TPU sleeves of sorts that fit over the fingers. And there's some special characteristics in the driveline, but we might not get into all of that. The last device we're going to make is a NIOP hook, which is a hook that will connect into the NIOP arm system. It will be a passive hook with a rubber band on it. So it won't require a driveline, but it will have the option. You could hook it up to the driveline also, because very soon in the next generation of the Quick Connect wrist, we will have an option so the driveline can run through it as well. In an effort to leave you guys with some of your meeting, I could go on for a long time about any one of these devices, but I will. I want to say before I even get started with this with the Kwawu that Jack did such an amazing job. I've learned not to to second guess his design work on much of this well, I should say I've learned not to discount his design efforts without really looking at it, because Jack had taken so much time interviewing and reviewing all the different techniques to get whatever result he was after. It's really hard to beat a lot of his things. And I mean, you come in and you're like, oh, this is something I could change and do better. But then you start trying to actually make it happen, and it is a difficult thing. Jack is on his game. It goes to show, even past mechanical design with the open scat and all of the extra little bells and whistles he added. So that said, there are still things that could be improved. I mean, it is a great design, but there's always things that you can do when people start nitpicking. But I just want that to be known as I'm saying these things, because Jack did an incredible job. Anyways, though, we're trying to make larger conduits in general in the hand. Now, Jack's already approached a lot of that, but the whole point of that is to make sure we have easy assembly. We've improved the weaknesses in the pinkies, and we're actually going to print the hand flat as the cover, and then the palm, by continuing the split at the wrist all the way through and making that another part for the QC wrist to connect into. So because we've cut the palm up in a different way with that cut across the wrist, now you can print it flat on the print bed, and it makes those weak spots in the pinky and in the palm a whole lot stronger. And I can't take credit for that one. That is R&D done by Michael Campos, who I have to say Michael did an outstanding job with almost all of his review of the Kwawu. He's done amazing work that I've been able to piggyback on and work with. I mean, he's been a huge asset to all of this. He's been almost as invaluable as Jack has been with working on Kwawu mods. And one thing I'd like to add that's really remarkable about Michael Campos's arms that I don't know if everybody's catching on to from just seeing the pictures, but his entire forearm is made out of TPU, or TPE, I believe. It's flex filament, and it has some bend to it, but it's a really novel design concept. When I spoke to Jack about how this works, he was a little cautious about it because he's like, when you get really tall parts, like printing an entire forearm made out of a flex filament, it starts to wobble on the print bed as it's moving around, and you get sloppier parts as you go higher. Now, Michael Campos has the luxury of being over at Matter Hackers and has all these great filaments and a print farm and all this stuff. So that wasn't such an issue for him, but it may be for others. At the same time, this is a worthy goal to pursue for the community because I think it's going to make a much better quality device. I mean, if you roll on that or lay on that arm, it's not going to feel like you just rolled over a log like it does with modern prosthetics that make that noise. So there's a bunch of stuff there to unpack also. But what we're doing basically, we're going to print it differently. We're already cutting the resistance out of the TPU hinges by putting holes through them, and that has helped a lot with a lot of the people who are field testing the Kwawu. The drive line will be changed to be a single drive line on the anterior side of the finger, on the bottom of the finger, and a single extension line on the top. And let's see, we're attempting to add more movement in the thumbs so it'll open further, so you'll have options to larger grips. We will be using the voluntary open system with the automatic grip. And the way the automatic grip is working is with a spring battery that will be, the term battery here I'm using is a group of springs. You will have 3 connections on the top and the bottom, and then you can change the configurations of the springs in multiple different ways to increase the tension by just changing either the gauge of the spring or the configuration and number of springs you put into the palm. And this will allow the maker to have complete flexibility to control the tension within the palm. And I think this is really important because when you go to really small cases, like what Michael Campos was dealing, he was dealing with an incredibly small scaled arm. And this way you can control the tension for the grip even on the smallest devices by using a smaller spring with a smaller gauge of steel in it. It will have less tension and be easier for a little guy or a little girl to pull it open and work it. So I think there's a lot of advantages to doing it this way for the makers to be able to customize devices. It's one of the bigger problems with the Kwawu has been the strength required to pull the hand shut. And it was actually so much that my scapula plate wouldn't work for the NIOP at first. And right now, for this first generation, we're actually switching to having to go to the brace concept just to secure the drive line. The device itself, the helix cuff will suspend the device, but the pressure required to pull the hand shut is going to stretch your back, so it's not good. And other than that, we are going to improve the cuff based on Donna Zimmerman's Zelix cuff remix of the Helix cuff. I'm looking to try and go into a Velcro strap again. So once again, just like the Exo glove to lay your hand in it, I want to be able to lay your arm into the cuff rather than having to slide it into from top entry. I want it to be front entry and top, I suppose. But I want it to be tighter than the original cuff was because that was one of the things the Helix did really well, and Donna's Zelix cuff does. The other thing we're going to be adding is a rotating thumb in the palm, and The generation after this one will be motorized, but this first generation, the way we're going to get rid of the TPU fingers is we're going to start printing the fingers as one part. They will have working mechanical hinges within each finger, so the different segments will all be the individual pieces, but the working hinge is printed as one piece. So each finger will be one piece that just pops into a socket on the palm. And we will be making a special knuckle cover to just seal those in there. So once the fingers are in, you can mess with the wiring of the drive line all you want, and the fingers don't fall out on their own. They will be mechanically secure, so you can mess around with all of the stringing for as long as you want, hang it upside down, dangle it around, nothing falls out. All right, so I have so much, I could go into details on all of these different devices, but rather than get into all of these, I'll let you guys just ask questions to get into specifics of these, and maybe I'll plan for return visits or something, I suppose if you'll have me, for talking about details of some of these other devices. And that might work better anyways, just because they are all still in progress, and in the coming weeks, both the Exoglove and the prayer hand will progress quite quickly. Leland is making amazing progress with that, like day by day. Alex too, though. And this is why I want to bring us to the QC wrist. This is the quick connect wrist connection that we are using. I am going to share my screen maybe here.
Nate, I'm going to jump in just for one moment. Oh, I was going to get the name of the person we had on the phone, but they just dropped off, so never mind. If they come back, I'll just have to get their name so I can put that in.
You can just hang on too, Jeremy. It's not like getting too choppy or anything.
Sounds good.
Okay, so here is the quick connect wrist, a section view of it. This is what Alex has been working on. The red section is actually what would be attached to the palm, and the groove, this is in progress also, and I have to apologize. Alex did an amazing job with this whole thing, and I don't want to slight her in any way with this, because this is basically what I wanted, but we will probably be turning the groove the other way around. And that was my bad for not explaining it to her the way I needed it done, but she did an incredible job here in general. What it's based on is an L-shaped slot that this key down here will slide into at the top, slides into the bottom, and then twists till this pin will engage through a hole. And so this quick connect wrist will be used, basically the palm would normally connect right here at the fixed side on the bottom, is how this would normally be. And that's why I'm saying it's like backwards kind of in application, but due to the beauty of 360, of Fusion 360, it should be really easy to flip it over. It's just didn't want to do that to Alex right before the meeting. She was trying to get things all coordinated so it would look pretty for the meeting. So concept-wise, though, you can get the basic concept that it will just slide in and then twist to pop in these side pins to secure it in place. Once it's in place, the hand will be there, and then you can just push the pins in, twist, and pop it right out to hot swap different terminal devices. And
Nate,
so
it looks from what I'm seeing like those pins are inserted from the inside. Is that correct? And if so, how do you get them in there?
it's magic. It's German engineering. So this plate, this section is pretty true. The red piece here will actually be about this shape and be printed in two halves, and then with a bolt running through it to put the two halves together. So the green pins will be able to be laid in there. There's going to be a compression spring that goes in between the two right here, and that will allow them to press in. We're probably going to have to clean out a little bit of this to allow the clearance to get them to go all the way in, but we can also pull the buttons in a little further too. But once that happens, you push these in, they'll always push back out because of the compression spring, and to assemble the whole thing, you'll have this half. You'll lay these two buttons in there with the spring in, and then sandwich it with the other half, with the other red half of the post.
I see.
It looks like one of these detent buttons, like on a vacuum cleaner wand. When you stick sections together, they snap together. You push the button.
Yes, sir.
So I was misunderstanding. So those pins don't need to go in and out every time you want to attach this to an arm. That's just that it becomes basically buttons that you push in from the outside.
Yeah, you push them in to pop the hand out, and then they'll push in automatically when you put it back in. That's what the bevel is on the top side of that. Actually, once the groove is flipped over, those bevels are going the correct direction.
Gotcha.
So
it's pretty brilliant stuff, Nate.
Thanks. And this is Alex. I can't take credit for all of this. I mean, I came up with the concepts for a lot of it. Actually, I stole the concepts from a Nerf sword handle that my son had. But,
That's great.
It was the right size and made out of plastic, so that was just what we were looking for.
Nate, your presentation is absolutely amazing, and your effort is amazing. I think everybody knows I had some concerns about my experience with assembling the Quo, and the fact that you're using springs. You're using springs instead of the hinges. I sleep better at night now.
Excellent.
Absolutely. Let me jump in real quick and ask who do we have on the phone in the 978 area code so I can rename you?
That's me, Patrick.
Okay.
Yeah.
Got it. Thanks. Okay, so anyone who wants to can come back on video and audio and maybe ask some questions, if that's okay, Nate?
Sure.
Nate, I had a case. Someone came into e-NABLE Web Central support and asking about our devices. It was about 3 weeks ago. And they said they needed it for work. And they wanted to know if our device could lift 40 pounds and 60 pounds with two hands. And I replied, no, I really don't think our existing devices. I said, oh, look, I'm not experienced, but I would be surprised if a Phoenix hand or a Quo arm could lift 40 pounds.
Okay,
but
to that end,
apparently is the need.
Yeah, okay, that need is out there, and I've been looking for that also. I've been looking to make adapters to do push-ups with, something that can have a flat hand to it. There's a lot of different things here. Some of these things.
Exercise push-up.
Whoop. Do we lose bandwidth?
I was just thinking of an angle. Continue.
Oh, okay. I'm looking at this as our devices should be able to get us like halfway to a lot of these specialized tasks. But I'm imagining that we start creating a lot of tools to work with the device hands to meet you halfway with certain things. There's a really cool shopping bag handle on Thingiverse. It's just a plastic handle that you slide the shopping bags over, and then you can hold the handle with the bag coming through the two fingers, and it works to hold shopping bags, even with a device hand. So things like that are kind of my approach to this. What I'm thinking is if you're trying to carry a lot of weight with this, and this has been an issue that Donna Zimmerman and I were discussing with Neil's strong arm that she made, that cool design. The whole point is the plastic can't put up with too much shear force with a lot of these things. So what I was thinking is you can run fishing line through conduits through the stacked layers in, like, say, a printed forearm. And then if the fishing line was run through it and taut, then you've got 100-pound fishing line as your structural member, almost like rebar inside of concrete. So you need to do a couple of those going around the arm, and then you would have pulling strength, right? It would probably also have pushing strength because it would the compression factor would push the layers together. That wouldn't be as big of a danger. So then your big structural stress would be in the wrist. So I would suggest something that needs to hold that much weight is going to need to either be made out of nylon there or PETG, but reinforced probably with string, or you might be able to get away with PETG if it was printed the right direction. If you got the layering set, so the layer weaknesses. The layer adhesion wasn't going to be a weakness.
I think also the orientation of the weight. I mean, if the weight is being put longitudinally on the device versus transverse, that would put a bending moment and snap it. You know, I mean, it's probably not a great need, but it may be something we all want to consider.
Well, we want to work towards that point because I quite honestly want an arm. From the beginning, I wanted an arm I could work on my car with, where I can grab like wrenches and just really pull on it. Or so John does have a good point in your socket and tissue pressure becomes a concern as weight increases.
Yep.
And that is true. So the point is to put the majority of the weight and the strain back into the person's back so they can use their back to pull, right? So especially when you're talking about a pulling force, that's where I like to think that we can probably accomplish this mechanically, is with that idea with the structural supports using fishing line through the layers. That way when you pull, you're really pulling on the strength of the fishing line, and if you have them on all sides, it will stop it from bending and cracking this way because you'll have the lines on whatever the opposite side is, giving it resistance. PETG will help also because it has some flexibility to it. I think ABS will probably crack because it will become, it's got a higher resistance for braking, but it's more rigid. And so I think that might actually be its flaw at some point.
Nate, I just want to echo what John was saying in the chat here. He's on the road, but I get so excited when I see these kinds of collaborative efforts where you've got a multidisciplinary team of volunteers from around the world, and you guys are working together and accomplishing such amazing things. It's really wonderful to see that.
Thanks. Yeah, it's a challenge too. But okay, so part of the reason why this is working so well is my first move was getting the entire team onto the same software platform. And I think that is key to success with this, especially when you're talking about trying to create a catalog of products, because at some point here very soon, we'll be able to actually cut and paste parts from one design into another. And at that point, we then will be able to run with this. This is all just an effort getting up to that point where that way other designers, you won't even need to know much about Fusion 360 other than knowing how to cut and paste.
That's right.
And you'll be able to take like Phoenix hand palm. I want these fingers.
That's right.
I'd like these tensioners.
Yeah, we've talked about that in previous calls, and we didn't really get into it here. But you're getting into this idea of modularity, which is so powerful. So the fact that you're building these with that modularity in mind is really powerful. You know that, like you said, whether it's with your other designs or as other designers start creating their own designs. If we can, this will start to establish sort of standardization. You'll have standard interfaces and things like that other people can start to build on and leverage, and we end up with modular frameworks instead of individual designs. It's great.
And that's it exactly, sir. And that is a very hard goal to achieve, coming at it from a scattered perspective, going up to order.
Yep.
Chaos hardly ever goes upwards that way, but you can start with order and control the chaos.
That's right.
Yeah.
So here's the inevitable question. When will the files be available when I can make the first one?
Okay, so to answer this one, Bob, the safest way to go about this is the Quick Connect wrist is getting really close. I imagine within a month, we should be able to have the Moto gripper and the Jedi gripper hand, basically all of Skip Meety's gripper designs. And this includes Dave and Ellen Took's mass-produced injection molded gripper hand. He's got a really cool thing coming with an injection molded design, so people won't even have to worry about putting hands together. You can just get one of his hands and screw it onto whatever arm. If it was a professional socket, it'll work on that, and we're going to make an adapter so it will then fit into the Quick Connect wrist. So that's a really great thing. But to answer your question, I'm thinking within about a month, the Jedi gripper hand will be available. We're about probably 2 or 3 months out before the Kwawu hands will be approved and ready to send out STLs.
Great, super. That's exciting.
I had a conversation with somebody, I think, was this you, Bob, where I was saying the fun part about pioneering is you don't have
Yes, it was us.
to get there.
It was us.
And Nate, as you no doubt know, one of the things that I love about the Fusion 360 platform is how easy they make it to share your source files in many different formats. Do you plan on doing that, making the source CAD files available too for people that want to?
Exactly. Okay, so the source files, I'm going to for sure make them available. I don't know if everybody's going to have full editing privileges of the source files, but they'll always be able to copy them and get downloads of the archives and stuff. Jack has done a really good job of this type of setup, and I'm going to try and do the same type of distribution system as what he used with the Qualu. Because he put a lot of thought into a lot of these things, so I don't want to remake the wheel with these points because he's done a really good job. And quite honestly, you aren't going to fix a lot of this stuff because we've had all kinds of debates about whether OpenSCAD is even necessary for this. But as you get into it more and more, OpenSCAD really does the thing that's hard to do with other softwares quite as well. Just because it's a macro-based mesh editor, it does what it does pretty darn.
Yep. Well, Nate, I definitely think we need to have you back more than once. I think we could have a presentation. We could have a presentation on each one of these designs, and then probably another one on your OpenSCAD work.
That would be great too. I've made a pact with Jack that if I came on here one week, he was coming on.
Good.
So we're gonna let.
Which Jack are you talking about?
Jakeem Buchanan, the guy who invented the.
Okay, got it.
Right. Colorado. So,
well, I would love that. Yeah.
Yeah, and so we'll probably try and get him in, and then I can definitely do follow-up ones. I don't want to take all the time from your meeting for sure, but I would like to say one last thing just for the community. As far as I've got a bunch of stuff I'd like to say at some point about assistive devices, so maybe that could be another follow-up one too, because like what I'm talking about with the shopping bag handle, I want to make tweezers that fit on your fingers so you can pick up your wheel stuff, and simple things like a TPU version of a writing device like this that would just slide over your thumb and then hold a tool. Like this one's for a pen, but I could make it easily to hold tweezers or whatever. Something like that. Real easy to print, and then it works on all kinds of different devices. But basically, as a last note here, I wanted to say that April, as part of another community building effort, the Amputee Coalition is attempting to make April Limb Loss Awareness Month. And so they were pushing to have people wear orange on Wednesdays during April and post it on social media with the hashtag LLAM for Limb Loss Awareness Month. So in addition to the wearing orange on Wednesdays, on April 27th, I wanted people to kind of know about this so they can put it on their calendar and prepare for it a little. They are trying to do Show Your Metal Day. And it's a signature social media event of Limb Loss Awareness Month. And Show Your Metal Day is the community's opportunity to flood social media channels with pictures of people with limb loss showing their metal, either prosthesis or metal, meaning how awesome they are. That's their direct quote from their little
METTLE.
Yeah, exactly. So we're all being clever here with our hand options. So if anybody can support that, the Amputee Coalition's color is orange. That's why they're asking for orange on Wednesdays. I will try and post a link on the Wiki Factory site so people can get more information if they wanted to. But I just want to make the general e-NABLE community aware of that, because I think we should try and help them with that, because that helps us too.
Excellent.
Good stuff.
All right.
Well, Nate, thank you so much. I'm sure there are still other questions. I will take the opportunity to go ahead and move on so we can cover a few other things, but we will definitely have you back. And thank you so much for all the work you're doing. It's really wonderful.
You're welcome.
Yeah. You're welcome to hang with us, but I understand if you're busy, you're welcome to drop too. It's entirely up to you.
I'd like to.
Great. So we'll move on to our individual updates, and looks like, Bob, you would be up first.
Okay. Doing the standard stuff with case facilitation, badging. We're caught up Web Central support. I become involved with sorting out some of the chapter processes, working with John and Patrick on responding to the people who submit chapter requests, and we have a new criterion that says you have to have a chapter badge. So we're working with those. We set the various requirements for that. I've reached out to people who have submitted recent requests, and indeed they are. Just this morning, 3 chapter requests came in, so it's working. The process is going, and that's pretty much it, Jeremy.
Great, thank you. Let's see.
I'm sorry. Let me just mention, I am working on an avenue of funding for e-NABLE Fund. Some calls this afternoon, so we'll see. We'll cross fingers on that one.
Great, thank you. So next up would be, it looks like, well, I guess me. So I did a test print recently because we have this new material called PL Active, which is an antibacterial PLA, and so I printed out a Phoenix hand. I put a little picture of it in here. It came out really nicely. It really prints well. It prints just like normal PLA. It thermoforms just like normal PLA. So, you know, the only downside is it is an expensive material. It's like twice the price of you know, at least twice the price of normal PLA. So I don't think it's going to be, you know, a top, you know, most popular, you know, item for most volunteers. But I think where it will be of interest is maybe some of these organizations that we run into, you know, clinics, hospitals, et cetera, that maybe want to start to get involved a little bit with this, but they have some hesitation. You know, this might give them a little bit more comfort, and we do have some customers like that already that are using this, you know, medical type places that have already started to embrace the material. So maybe this is one way that we can start to, you know, overcome some of that hesitation with these kind of, you know, amateur devices, you know, and so, you know, that sort of thing by offering this option of an antibacterial material. So,
Jeremy, how do you test the antibacterial properties, or is it just certified with data to be antibacterial?
That's exactly right. It's certified and lab tested, and I pretty much rely on their data. They have extensive white papers showing how they did their testing. It deals with nanoparticles and things that I don't understand, but it has been extensively tested.
So it could be kind of overcome psychological objection.
Exactly right. Yes, that's exactly right. Some statistics for our
getting feedback from Patrick, I think.
Oh yeah, Patrick, did you have a question?
No, I was just saying, is it like an antimicrobial, like a coating or a porous thing? But I didn't know we were just discussing the component of it, not the actual.
Yeah, it's something that they've incorporated it into the plastic itself somehow, so that anything that you print with it has antibacterial properties.
Germs?
That's awesome. So even like war zones and stuff, it could be used.
As far as I'm aware, yeah. What was that, Nate?
I was going to say, there's brilliant applications for this. Like the teams that are out in like Syria and Thailand, they could print things like all kinds of medical devices, like the tweezers is an example I was just coming up with, like other medical devices outside of just the medical device. And any of these assistive devices I was trying to come up with that would be used for eating, that might be a really useful thing.
Exactly. That's some of the test prints that the manufacturer shows are exactly those types of things. So I think you're exactly right.
Cool.
Yeah.
I wasn't aware of that. That's very cool.
Yeah, it's neat stuff.
I'm guessing there's a silver compound in it or something.
I think you might be right. Yeah, I'd have to go back and read the details.
Silver tends to be the cheapest, believe it or not, antibacterial.
Right. So our help desk ticketing system, which has been pretty active, we have handled over 700 tickets so far since we started this in late October, and a lot of that has been Bob and Wayne handling all of the badge requests. So as of now, we've had 353 badge requests, 35 general e-NABLE support tickets, and 315 e-NABLE Web Central tickets. So everyone's doing a great job staying on top of those, I think. Not a whole lot to report this week on e-NABLE Web Central compared to what we reported last week. We're still working on the next update, getting that rolled out, which will allow us to share publicly accessible URLs to our profiles if we want to within e-NABLE Web Central. So you'll be able to actually give somebody a link to your profile if you wish. So that'll be coming soon, and of course there's this very large usability improvement initiative that we're working on with the Deloitte and Adobe teams, and I look forward to giving further updates on that later.
Jeremy, have we hit our 100th device yet?
Yeah, I'm sorry, I should have mentioned that. Thank you. I skipped right over that. Yeah, in the stats here, I noticed that today. So we did just deliver our 100th device through e-NABLE Web Central. Thank you for the reminder, Bob.
Congrats.
Yeah, yeah. I have mixed feelings. On the one hand, I wish it was 1,000, but we're going to get there, I think, with the usability improvements we're working on.
You have to get to 100 first.
That's
Jeremy.
right. That's right.
Very good, Bob. That's what I was going to say too.
You're exactly right. So yeah, that's an exciting milestone, and I'm excited for what we're working on. I think that'll open it up to a much wider audience. So that's my update. So John, if you're able to talk to us, you're up next.
Yeah, as no is simple.
A little choppy, but let's see. I think you'll be okay.
All right. So the collaboration with Dell Computer, thanks to Ed Krieg and company at Deloitte, is going well. They have now sort of an exhibit plan for Dell World that will have 6,000 participants. They'll be demonstrating in hands. They'll be handing out materials. They'll be encouraging employee donations. And they're doing really good hands-on enabled volunteer work as well. So they're good collaborators. I think that Seamus in Texas is also going to be able to help us with AdWords and SEO and all of that process of presenting ourselves more effectively to the world. So that's great. Dell has also pledged a multi-$1,000 donation, which we are very happy about. So they are, a corporation, and as individuals, they are welcome partners and collaborators. As we discussed the materials and their plans for making it easier for people to sign up at the event, it became clear to me that we need a simple and clear landing page. Right now, the embarrassment is that we have many landing pages. WikiFactory, enable.org, enable the future, etc. So I'm going to work with Ed and try to have them develop something that will start by making things clear and simple for people at Dell, and may become a target for us. It's not clear how that's all going on to the next position, the next topic. Then I will point out that we are migrating SPC material. This is thanks to a lot of work by Jeremy, from e-NABLE.org to WikiFactory. I think WikiFactory is turning out to be a really good and powerful platform for us, and we're now thinking very seriously about pointing the enable.org domain directly to an approved landing page in people. To that end, Jeremy and I are going to be meeting with Christina from WikiFactory to look at a customizable template that she's preparing for us, so that we can make people's first visit to that WikiFactory URL that we explore, so that we can make it look the way we want. That, for example, it won't just show the most recent projects, but the ones that we think are most relevant, and so on. So it's not clear how that's going to work out, but it's moving very quickly, and I got to say it's moving pretty smoothly.
Good. Excellent.
That's great, John. I really appreciate that. I mean, I'm kind of new to this whole scene, because I hadn't seen a lot of this other stuff happening, but that is a huge advancement for the community.
Absolutely. And, Nate, they're very receptive to our requests and suggestions for improving their system.
Excellent.
I personally think the project's utility that they have is potentially very powerful, but I I still haven't figured out how to use it well. Your project is precisely the kind of thing.
Yeah, I don't know if you caught on earlier, John. I was apologizing for not having already done this because I agree 100% with all of this and the point that I should be using it and I haven't done it yet. I agree with all of that.
Well, none of that was meant to be browbeating. The point was that it's powerful, and if you, for example, and I'll be really interested in doing this with you or Super try to do that, I think we'll probably be able to surface some features and improvement that we'll be very interested in accommodating.
I'm in. Deal. I'll totally do that. That sounds like a great thing.
Okay, great. In other news from Rochester, our summer program is shaping up really better than we could have hoped at the Rochester e-NABLE Lab. We are now working with one of the faculty. She teaches physics at Virtus. She's working in the lab 3 afternoons a week just on a volunteer basis, but she's going to be on board half-time and is going to be developing a curriculum which will be integrated into Virtus's intramural curriculum, which will be a real advance. We also have someone, I believe, who will replace Melvin, who's going to be doing a 3D printing co-op in Costa Rica with Boston Scientific, which will be great for him and for us, but they're really very interested in all of the expertise he's got, and he'll be bringing back knowledge for us. We will also be hosting some interns. As you know, we've had some fantastic interns. Chad Johns, who won an international award last month, and Tyler Bray, who's popping up for doing stuff. But we'll have 2 interns from Kuala in Honduras, which group, I believe, is a regional conference for a year from this summer. So supporting that group, especially as Melvin goes on to the professional, seems like a really good investment. So that's all just terrific. It's supported by a few donations to Rochester e-NABLE Limited, a small amount of money that we get as the effect of our organization of the e-NABLE Fund, and from the really generous and great support of the Virtus School, which really values what we're doing. Finally, I'm going to be, in May, going to Berlin, where I'll be speaking at which is an online digital social action conference. We'll probably also be going to Munich, where there's a group of academics who are looking at things like e-NABLE as well as other online assistive technology groups. Those dates are roughly the 6th to the 10th, and I would love to meet up with people along the Berlin-Munich axis. Then I'll be going to Thailand, where I'll be part of that Singularity University workshop. That is being organized by Scott Summit, one of our early collaborators, and for a short while board member, as well as Andy Christensen, who was a board member of e-NABLE Community Foundation, who I have not seen since those old days. So that it should be an interesting encounter and rendezvous. And then I will be returning to New York City, where I may be in New York and possibly in New Jersey for a few days at some related. So from the 6th to the 21st, I'm going to be bopping around the transatlantic region, and I'm always interested in rendezvousing with people, this time in Berlin or Munich or the New York area. And that's my report.
Okay, thank you. So we are running, excuse me, we are running long today, but I want to try to get Maria's and Patrick's updates, and we'll probably have to sort of hold off on the rest of the agenda items. But Maria, you have any updates for us? Maria, are you with us? You're on mute.
Hi, Patrick can start.
Okay, Patrick, you want to go first?
I don't want to lose anything he has to say.
I was going to say, skip mine. I'm learning stuff again this week.
Well, I know you're involved in helping John and Bob, but something having to do with the chapters. Maybe you want to give us an update on what you're doing there?
Think of an animal. Yes, we're pretty much trying to. The Kumu has a way of doing spreadsheet, where spreadsheet acts as the tangible items. I'm just trying to find out how to do like a production and develop a map and have that process have at least enough dates to be processed properly, and that's it's going well. I'm just trying to learn.
Okay, sounds good.
Okay.
Fun.
Marie, I don't know. Are you ready for us?
Yeah, yeah. How are you doing?
Good. How are you?
Hi,
Hi,
thanks
Maria.
for Capital Technology University today. They're going to be hosting some of our workshops and some of the camp activities, I'm hoping. We have camps right now being organized in regions of the world. We're going to be networking with each other and swapping some of the things that we make with each other, which is terrific. So that will include youth within the U.S., youth here in the Baltimore, Washington area, youth in Boston, youth in California and Florida and Texas and the Midwest, as well as youth in Mexico. One of the first camps already took place in Bogota with Christian Silva's group, body modification camp that went extremely well. We've had 2 deconstructed hackathons already to prepare to test drive the materials that we're going to be using. And the pathway for the youth program is going to lead to keeping the groups organized using the knowledge base. Using the knowledge of the engineers that are working with us from Johns Hopkins Applied Physics Laboratory and medical volunteers from a number of different hospitals and some people from the Hanger Clinic. So this network is really working well. One of the groups that we're patterning some of our materials from and sharing is the AIM Academy. People have been rallying around the printing for a class, developing some curriculum connections with it, including some social justice components to the academics, and having a purpose for every hand that's made. And I can't stress enough that at least with the e-NABLE Alliance, that's extremely important, that there's a purpose for everything that's made. And so being able to direct within a decentralized community a really well-distributed network, it's really been a wonderful thing to see working well. We have a new LMS. We have a relationship with a partner whose LMS platform is government certified. So this gives us leverage now for us to be able to develop a CME that would also be useful to the medical volunteers I have at the Uniform University in active service and the medical volunteers that we're working with in the VAs. We've worked in the past with the VA Centers of Innovation, but we're also working now with Warriors Project, and so that LMS system is an important thing for us to have for our community. We're advancing more support for the enabling-the-future.org website, including an expansion of the storytelling workshop that we did at EnableCon last winter, which was storytelling as a currency of trust. So we actually have a story that we were working on for the limb loss awareness. So Nate, I have to give you props there for keeping that on people's radar. Also, this past week was the Autism Awareness Day, and so I wanted to highlight some of the work that we have done with youth on the autism spectrum and how the ENABLE process has proved beneficial there, and that we have a tactile objects collection that's also something that people should be aware of. We worked this past week with the Alan Alda Center for Communication of Science, and we had a hill walk with youth who were engaged in FIRST. They were accompanied by Dean Kamen. So we have a number of stories that we get to share on that website, and we're finalizing the challenges that we wanted to issue for the spring and summer. We have a partnership now with the Bounties Network, and so that will allow people globally to participate and to receive a bounty using a blockchain. That would allow the groups who we're working with in refugee camps who are allowed to earn money to receive payment even though they're completely unbanked, and for them to be able to receive materials as well. So we've been working out those relationships with the Government Blockchain Association. That's a group that's also been presenting to the community through EnableCon for the past couple of years. The conference is going to be slightly different this fall. The theme is the same. The status, so the state of the technology, of the science, and of our enabled community. We have additional tracks, and some of the workshops are being held in conjunction with the Medical Reserve, including a one-day complete training. It's a variation on the 3-day mental health first aid program. And as part of those discussions for the past month, we've outlined as vulnerable populations, people that we need to have special training and awareness for, the parents of recipients and also young professionals. So we're looking at ways to roll that out, but also to talk about the stresses that people will experience as part of this work, not needing to be in the field, but just as compassionate people, and to give people a vocabulary and also channels to use within our community to address that. There are new tours. There are a lot of tours. Some of the tours will require some experience and some vetting in order to go, because they are representing the community there. Some of the tours are not open to people who are not U.S. citizens, because they're going to places that are secure, like the ones we had at NASA and at the Applied Physics Laboratory and at the Food and Drug Administration. But there are other tours available during the same time periods. And then lastly, with the discussion of the conference, there's also a track to focus for at least a brief period of time on materials and on the sustainability issues that we've been working on. We'll have more information about that on the Enabling the Future website on Earth Day, which is at the end of this month. So if you're looking at the calendar, you're wonderful. That's one more date to add right after the Show Us Your Metal Day at the end of the month is Earth Day. To be aware of that. There was some citizen science that took place in scattered areas of the community during Earth Hour, before things went dark, to look at how much power 3D printers were using for an hour, using the kilowatt monitors. And some of that is really fascinating, but I think I'm probably redlining on the geek meter when it comes to that. But what we showed was that you are able to use solar panels and batteries that are available from groups in order to power 3D printers, and talking about the work that's been done at the SUNY Polytechnic Institute for 3D printing in the field. So lastly, there are currently probably 4 college credit courses that are focused on Enable, and it's crunch time for those right now, and looking at how to expand those into capstone projects in the following terms. But I have to give a shout out to University of Maryland, College Park, and their 2 credit course on 3D printing medical devices. They've opened a whole building dedicated to medical devices development. I'm hoping to show that off to all of you when you come, and also to the SUNY Polytechnic Institute and the student groups there. They've expanded the utilization of the enterprise level software that we have for them, and learning how to do supply chain management and inventory management, and also in learning more about the Project Alchemy, that recycling project we were talking about in past meetings, and then looking at the development of other resources. So this has been a really busy time. A lot of good research is taking place, and a lot of good feedback has been coming in from people who have worked on the projects. Especially, I'm really gratified to see the expansion of the number of medical volunteers engaged with us. And I'm hoping that the LMS platform will open that up to the broader, even global community. So that's all I got.
Great stuff as always. Thank you.
All right.
God, you have so much going on. It's wonderful. That LMS will be really. I look forward to seeing that.
It's fine to be decentralized, but now they're really strong, distributed network too.
Oh yeah. I really look forward to seeing that LMS. I think that'll be a very powerful thing to have and can be used in a lot of ways.
I think I need to go back and revisit Ergo Creo for us too. One of the things that really stood out over the past term has been the need for developing a safe space that's credible to educators with with requirements for the volunteers who are in that space, and defining that. And that's one of the things that we've been working on earnestly. The Parsons School of Design classroom that is going to become a living classroom in the next terms, they're spinning it for us at the end of this month, and that's going to give us some ability to produce materials that will be able to share more. But in the meantime, there's a lot of work that needs to be done this month to define what that safe space is, and to help people to begin to operate in that. And that's going to be part of that set of requirements for some of those tours. It's genuinely, those are the opportunities. I can't pay people, but I can certainly give them opportunities to do things, and that'll be part of it.
Great.
Any questions?
Not for me. Anyone else?
Right. Thank you, guys.
Yeah, that's all awesome. Thank you.
Okay, so I'm going to have to go ahead and wrap because we're running along, so we'll cover the rest of these topics next time. Again, thank you so much for your presentation, Nate. Just fabulous work, and we'll definitely have you back and have Jack come and talk to us. Look forward to that.
Excellent.
Okay.
Yeah, thanks for having me. I really appreciate the opportunity, everybody.
Oh, I forgot to tell you one thing. We've gotten our first funds from United Way, so this is another pathway for fundraising for the community that we can use.
Awesome.
Great.
Yeah.
Congratulations.
Thanks. It's good for all of us.
Thank you.
Okay, so I will get a recording out later, post that to the new page in Wiki Factory. It'll be on the SPC page, and I'll try to get that out later today. Talk to you all next time.
Great. Have a great week, everybody.
Bye-bye.
You too, everybody. Take care.
Bye.